Now we'll be finding the domain and range of discrete functions. Discrete functions are not connected. These are dots. So on your paper, go ahead and just draw a bunch of dots all over the graph. So this is a discrete function. It could be any number of dots. This is discrete. A continuous function is a continuous line where all the points are connected. So this could look something like this. The key, remember though, the function is that x never repeats. So the x values never repeat itself. So that's what makes it a function. Sometimes there's discrete graphs that are not functions, and sometimes there are continuous graphs that are not functions. But for now, we're focusing on functions. And as a reminder, your domain are your x values. These are also your input and your independent variables. And you read it from left to right. So the smallest number to the left, all the way to the biggest number on the right. So you read it like a book, from left to right. Range are your y values. This is also your output and your dependent variable. And you read this from bottom, the smallest number, to the top. So from bottom to top. Oh goodness. So let's look at how we find and write the domain and range of discrete functions. So remember, these are just the dots. So these points only. So for domain, I'm going to use all the x values. So remember, domain are the x values. So I'm going to write this as x equals, and then parentheses, or the brackets, whatever this is called, this swirly thing. And I'm going to list all the x values. A key takeaway is that you don't have to repeat any numbers. So if any of these numbers repeat, you don't rewrite it, you just write it one time. But none of these repeat, so I'm going to write all of them. So domain are all of your x values written from smallest to largest. Your range are going to be your y values. So I'm going to write these as y equals, and then I'm going to use that swirly bracket thing, whatever that's called. And I'm going to list all the values, but make sure you don't repeat any. So if I have, so none of these repeat, so I'm going to write all of them. So negative 23, negative 14, negative 8, 1, and 10. And then I'm going to end the swirly bracket thing. So that's my domain, are all the x values, and my range are all the y values. Let's do it again. So my domain are going to be all of these x values, but make sure they don't repeat. So domain, negative 4, negative 1, 0, 2, 7. So you just list all of the x values. And for the range, you list all of the y values. Remember, y is the same thing as f of x. So these are your y values. So we have negative 5, 0, 1, 2, and 4. So I have my domain and my range. All of my x values are my domain, and all of my y values are my range. So now let's look at the ordered pairs. The domain are going to be all of the x values, you guessed it, and whenever I have my ordered pairs, I like to underline the x value. So my domain is going to be -2, 0, 1, and 6. My range is going to be all of my y values. So remember, x, y, x, y, x, y, x, y. So all of my y values are 3, 4, 1, 0. So when I look at a graph, I can do the same thing. I can either write out all the coordinate points, so I can go -4, 5, and do that for all of them, or I could just eye it. So domain are going to be all of the x values. So I'm looking on the x-axis. So this, so -4, -1, 2, and 3. And remember, we're reading it from left to right, so that's why I did it in this order. Then we have the range. That's going to be from bottom to top. So I'm going to go in this order now. So I have -2, the next point up is 1, the next point is 4, and the last point is 5. So I made it look a little complicated, but it's just domain is all of the x values, range is all of the y values. So now we look at a table again. Remember, we don't repeat any values. So for the domain, I'm gonna write -5. Don't repeat. -3, 0, 2. So we do not repeat values. Then we have the range. So remember, we write them from smallest to largest. So I have -5, -3, 0, and 6. So -5 is the smallest number, -3, 0, and 6.